Hello everyone, welcome to Tech with Machines. Here today we are at day 5 in solving our data structures and algorithm problems. I hope you are enjoying these videos in the same way as I am enjoying by learning and creating these videos for you or along with you. If you haven't subscribed yet, please subscribe so that you can get notified about these videos, and if you don't want, that's also fine, but remember to give a thumbs up if you like the video. Now on day 5 we have a new problem called MoveZeroes. So we are given an array of integers and we are supposed to move the zeros to the end of the array, ensuring that the order of the other elements remain consistent, right? As an example, in this case, in the input we have 2 zeros and we have 1, 3, 12 as well in the array. So when we move zeros to the left to the end of the array, 1, 3 and 12 are coming to the beginning, and that's what is our output now. If you remember, in the previous video we learned a technique called two-pointer technique, and I mentioned that we can use 2 pointers, right? In case we have a sorted array, or in case we want to basically are dealing with some kind of a position in the array. Now in this case specifically we're dealing with the position because we have to move zeros to the end of the array, right? Now 2 pointers doesn't necessarily need to be at the beginning or at the end of the array, which we have done in the day 4's problem. In this case we are going to initialize both the pointers at the 0th position. So what we are going to do is we are going to keep left at a 0 and also right at 0, which means both are at the index position 0, pointing to the element 0, which is in our input, right? Now whenever we encounter a non-zero element, so we have discovered our first non-zero element, right? While iterating, whenever we discover our first non-zero element, we are going to swap left and right and increment both, right? In this case, left is actually tracking the position at which it has to be swapped with the non-zero element, and right is moving ahead by pushing 0 to the end, correct? Now in case right again discovers the next element is 0, just right will increment because it has not yet discovered another non-zero element for it to be swapped with left. Like in this case, at the right, until right reaches the end of the array, that will be our loop. So in this case, in the iteration 1, what will happen, and also one more thing which I wanted to clarify, that I interchangeably use iteration 0 or iteration 1. In case I am using iteration 0 in any of the videos, I meant the first position in the array starting from index 0, or if I'm doing iteration 1, then it's exactly same. I'll try to ensure that I use a consistent language, but in this case let's go ahead with the definition of iteration being starting from 1, which is nothing but a step 1 at the index position 0, right? So in this case the first element is 0, so which means the right has not yet discovered, right pointer has not yet discovered the first non-zero element, so right is going to increment in iteration 1. So in iteration 1 what will happen is our right will become 1, right? Now when iteration 2 comes, which is index position 1, it discovers its first non-zero element. Now in this case what happens is right increments, right becomes 2, but left also increments. Left also becomes 1 because now I have found my first non-zero element, so I'm just going to swap it. So in this case what will happen is the output, basically the array, will become 1 and 0, right? Because we have found our first non-zero element and we swapped the left with the right. Now left came at this position and right came at this position, correct? Now in iteration 3, which is the index position 2, we again found that it's a 0, so only right is going to increment, so right becomes 3. So right basically becomes this position, right? 0, 1, 2, 3. Now in iteration 4, it is non-zero element, so it's gonna swap. In this case what will happen is, as it is going to swap, left was here, so this will become 3 and this will become 0. Now both will increment, so right is going to become 4 and left is going to become 2. So basically left is here and right is here, right? Now in iteration 5, which is the last iteration, we have element 12, which is again a non-zero element at position 4, 0, 1, 2, 3, 4, and our left is at position 2, 0, 1, 2. So we are gonna swap that with the right element. So in this case, what will happen is this will become 12 and this will become 0. Now right becomes 5 and left becomes 3. Now as you can see, we have already exceeded the length of the array. We have gone out of bound here. So our loop has terminated now and we have gotten our output where zeros are now moved to the end of the array. In case there were all 0 elements, and our right would have only incremented, left would have never incremented because we would have never discovered any non-zero element, right? So this is solving it in place, and it's a linear time, and it's a very efficient technique, two-pointer technique, which gets used in arrays and linked lists. So you are going to enjoy this technique a lot. Now let's dive into the code. So as usual, I have already created a class called MoveZeroes and I have initialized it with the numbers array. I have created a function called MoveZeroes and I have done exactly whatever we just did a dry run of. We initialized 2 pointers left and right, both starting at index 0, and until the right goes out of bound, we are checking whenever we are discovering a first non-zero element, we are swapping left and right. And we are incrementing left and right both. In case we don't discover any non-zero element, we just increment right. So if I run this, it's going to return me exactly the output which we just did a dry run for, where 0 has been moved to the end of the array. I hope this helps and you are able to solve it along with me and maybe much efficiently than me. And I hope you enjoyed this video. Please remember to give a thumbs up and also please subscribe if you like the video. Thank you very much. Happy learning.